Belt drives are widely used in modern mechanical engineering. They are used in machine tools, presses, cars, agricultural machines. The Dawn Company, for example, has over 20 different time programs. The temporary transmission consists of two or more pulleys, on which a belt is tensioned, transmitting the circumferential force by friction. Compared with the gears, the belt drive has large dimensions, slightly less efficiency. They do not provide synchronicity of shaft rotation, but despite these limitations, the scope of their application is very large. Variable transmission is distinguished by simplicity of design, low cost, noiselessness, good damping and damping properties. The gears can be used at any location of the shafts in space. They allow stepless speed control. Among belt gears, there are gears with flat, wedge, V-shaped and round belts. In a flat belt transmission, the friction force is dispersed over the width of the belt and all elements are loaded evenly. Rubberized, leather, cotton and wool belts can be used in the transmission. The most commonly used flat rubberized belts. These belts are used at speeds up to 25 to 30 meters per second and small stresses from pretension. The weak link of such belts is stitching. The belt is heavier and stiffer here, shocks and vibrations occur. The introduction of high-strength synthetic materials with friction coating made it possible to create thin, lightweight high-speed belts with a high coefficient of friction and high load capacity. They are used in transmissions with a capacity of up to 1,500 kilowatts. The small thickness of the belts allows the use of pulleys of small diameters. Endless flat belts ensure smooth running, which is especially important where it is necessary to avoid vibration of the working bodies. In a V-belt transmission, the V-belt operates in the groove of the pulley with the side surfaces. With the same radial force as in a flat belt drive. In a V-belt transmission, the normal force is greater. Therefore, the jamming action of the belt in the pulley allows you to develop traction forces more than in a flat belt. With the same transmitted power, the V-belt transmission requires less belt tension, therefore, the forces acting on the shafts and supports are also less. The V-belt transmission allows small girth angles on the pulleys. Therefore, it can be used with smaller axial distances, large gear ratios. It is successfully used in transmissions with several specific pulleys. However, due to the large power losses due to belt bending, the efficiency of the belt drive is lower than that of the flat belt drive. The possible variability of the cross-section dimensions along the length of the belt causes fluctuations in its branches and torsional vibrations of the driven system. Belts are made of Infinite 2 designs. In the Cort fabric belt, the Cort consists of several rows of fabric. And in the Cort and the Cort poured in a spiral. The Cort is a load-bearing traction element of the belt. The outside of the core is wrapped in one or more layers of rubberized wrapping fabric. Rubber pads are located above the bearing layer in the stretch zone and below it, in the compression zone. This design causes good damping properties. Cort belts are more flexible and durable, provides greater efficiency in displaces Cort fabric belts. In general, mechanical engineering mainly uses belts of normal cross-section. Their disadvantage is that when stretched due to the deflection of the belt in the groove and the eccentricity of the application of friction forces, the load is distributed unevenly across the width of the cord. The introduction of high-strength polyester cord made it possible to create narrow belts in which the load on the cord is distributed more evenly. Such a belt allows for greater speed. To transmit the same power, narrow belts require half as much. The transmission with several V-belts on the pulley is affected by the heterogeneity of the elastic properties and sizes of different belts that are not equally located in the grooves. The gear ratios of individual streams can be different and the load on the belts is distributed unevenly. On V-shaped belts consisting of a flat part and wedge projections, an error in the size of individual teeth does not affect the location of the cord along the entire width of the belt. This ensures a quieter transmission operation and a greater load capacity. Similarly to polyclinic belts, multidisciplinary belts work, in which normal V-belts are united by a common basis. Adhesive belts are also successfully used in speed variators. The variator pulley consists of sliding discs forming a groove. The speed is adjusted by changing the gear ratios with the movement and sliding of the discs. The wider the belt, the smaller the angle of the wedge and the diameter of the pulley, the greater the adjustment range. These requirements can be met by the selection of materials and construction. The belt. For example, reducing the groove angle with the same belt tension increases the normal force compressing the wide belt. The belt deflection in the groove increases. To increase the rigidity of the stretch and compression zone, several layers of fabric are introduced across the belt. To work on pulleys of small diameters, variator belts must have longitudinal flexibility. They are performed mainly with corded cords with lower teeth. Reducing the belt cross-section due to the teeth improves longitudinal flexibility, does not reduce traction abilities, since they do not affect the load-bearing cord. Wide belts of special sections are used in variators of motor vehicles. Scooters and snowmobiles with maple variators do not need a clutch. If the variator is turned off, the drive pulley discs are pushed apart and the belt lies on the bearing or shaft. When turned on, the variator first works as a clutch, and then as a belt drive at the highest gear ratio. Moving the discs adjusts the speed. For systems with a spatial arrangement of axes, round belt drives are convenient. Let's consider the basics of operation and calculation of belt gears. The tension required to create friction between the belt and the pulleys causes tension stretching. When the belt is stretched by the force F0, the belt stretches by the amount of lambda p from the machine part is deformed in the direction of reducing the axial distance by the amount of lambda d. Centrifugal forces arise in the belt during the running of the pulleys, creating additional tension of the Fc. Under its action, the belt tension at idle increases, the belt lengthens. Thus, with fixed shafts, with increasing speed, the force of pressing the belt against the pulleys and, accordingly, the friction forces fall. In gears with automatic tension, the clamping is determined by the weight of the load or the force of the spring and does not depend on centrifugal forces. When the transmission is loaded, the tension of the driven branch decreases, and the leading one increases. The branch tension ratio is determined by Euler's formula. The leading branch experiences a greater tension of stretching. In addition, bending stress occurs in the belt on the pulleys. Thus, each element of the belt undergoes variable stresses during operation. At the point where the leading branch runs into the small pulley, the voltage is maximum. When the belt fits the drive pulley, its tension force decreases, each element of the belt shortens and lags behind the pulley. During the fit of the driven pulley, the belt tension increases, the belt elements lengthen and outstrip the pulley. This is how elastic sliding occurs. The driven pulley loses its rotation speed. Sliding is also explained by speed losses due to congenital deformations. Experimentally, the dependence of sliding on the relative load, characterized by the coefficient of traction, was obtained. There is no sliding at idle. At low and medium loads, the sliding curve is close to a straight line. With an increase in the load, the speed loss increases sharply, and at maximum load, the belt slips. In pedigree gears, especially in variators, additional speed losses occur due to transverse compression and radial movement of the belt. The greatest hysteresis losses occurring on the pulley when the belt bends in it, as well as losses in bearings and aerodynamic, do not depend on the load. Therefore, the transmission efficiency at low loads is low. As the load increases, the efficiency increases, reaching a maximum in this interval. And then, as the distortion increases, it drops sharply. The criteria for the operability of the belt transmission and the traction properties and durability of the belt. The traction capacity, characterized by the circumferential force, increases with an increase in the coefficient of friction and the angle of girth. Therefore, friction coatings of flat belts appeared. V-belts without wrapping, gears with guide rollers that increase the angle of girth. Friction forces decrease with increasing speed and centrifugal forces. Hence the desire to lighten the belt, switch to narrow wedge and thin flat belts. The durability of the belt is limited by fatigue damage caused by alternating stresses. The experimentally obtained fatigue curve reflects the dependence of the number of cycles to failure on the maximum stress. Durability decreases dramatically with a decrease in the diameter of the pulley and an increase in belt tension. Therefore, it is preferable to use an automatic tension that provides the minimum required value. The calculation of belt gears is carried out on the traction capacity of durability, taking into account the variety of shapes, designs, materials, belt manufacturing technology in gear operating conditions. The advantage of temporary gears ensures their wide application in a wide variety of machines.